on the Kubernetes. I'm going to start the things from very zero, from base bottom up approach. The way we plan this training, there's no prerequisite. Okay, we will start from very basic. Okay, and slowly I'll explain the concept of single node, multi-node. There's a lot of component in the Kubernetes, like etcd database or kubelet and kube proxy and kube schedulers and kube controllers. I will explain those component, overlay network. I'll explain this point to you. Then we will discuss about a lot of Kubernetes internal concept. Okay, what is different kind of deployment strategies? What is replication controllers or replication set? What is pod? What is container inside the pod? Why we have multi-pod, multi-container pod? What is different design strategy we use? What is services or load balancers? That's called networking. So a lot of things we plan for today. And what I'm talking about at this point in time, everything would be with a pure hands-on and practical, right? So there's no, I don't use mostly the PPT and just keep on scrolling the PPT. I will explain you one concept, then we do the demo. I explain the concept, we'll do the demo. I also teach you how to set up the lab. Okay, so if you want, you can do the demo along with me, or otherwise you can just listen to me. My team is preparing the notes and reference document for you. We'll share the reference document, and if you would like to practice in the future, we will help you. Plus, you can also follow the document for the practice. Okay, so there's a very quick information about, but don't take this training the sake of just getting just a knowledge. The way I started right now, this is a very serious tool. Okay, when I say it's very serious tool, so if you just search very quickly in the Google which all companies are using Kubernetes, okay, I feel you can see almost every company. Okay, from from cloud providers to government to research organization, to banking, to finance, to any service oriented company, product based company. Okay, almost every company from basic to all the core MNCs, top level company are using Kubernetes, and they have, because they are using Kubernetes, so they have a huge requirement. Okay, even though if you look about Indian government is deploying a lot of their workload on Kubernetes. Okay, and one of the favorite tool of you guys may be ChatGPT from the company called OpenAI. Okay, and you guys might know it's not small thing, because if you talk about OpenAI is a machine learning LLM model, large language model, and to creating this model, this called model training. Those who know machine learning, so model training, right? After training your model, created that what we using ChatGPT model behind the ChatGPT. Okay, so if you talk about OpenAI, they trained this model by using some thousands of GPUs or thousands of node. Okay, and only GPU is not the enough thing. They use many things also along with it. They need some storage, they need some networking, they need many other things. They have to manage they have to monitor it, they have to they have to scale it as per the requirement gonna come up. Okay, OpenAI is completely rely on Kubernetes. The ChatGPT, what you are using right now, it is trained on the top of Kubernetes cluster. Okay, if you talk about the game, any game, any top games in the market, Pokemon Go. If you go talk about the Pokemon Go, is completely run and deployed on the top of Kubernetes. So my point is, I just giving you multiple examples here. Even though we can go and check very very quickly, if you just search for Kubernetes. Okay, this is the official page for the Kubernetes, official page of the Kubernetes. And first of all, guys, Kubernetes is software. Actually, it's not a device or not the appliance. It's a software that you can install in your laptop also if you want. And one of the things what they show you in the Google search, the OpenAI case study. And if you click on the case study of the OpenAI, OpenAI, then this is the complete case study you can find how OpenAI, that means ChatGPT, use Kubernetes behind the scene. Okay, so OpenAI impressive Kubernetes as a tool for auto scaling. What is auto scaling? We'll discuss. They distribute the training, what is running behind the OpenShift, and because obviously for model training they have to do many experiments, and they done the experiment within 3 days, and so simple to scale in thousands and thousands of GPUs. And because of the Kubernetes, Open AI scale up 10x to 50x. It's not a small thing. That must scale they have done in the Open AI. Okay, and behind this, there's a lot of things they use in the world of Kubernetes. So, what all the component? That's what my duty to teach you and train you, and why they Kubernetes help Open AI achieve this part. Okay, because there's a lot of vocabulary. Okay. Vocabulary they are having behind the scene. That's what we will also discuss. So don't worry, I'm just trying to tell you, okay, this is not just a tool just for learning perspective. It is a tool what we use directly in our real environment, in our real scenario, in our real production environment. Even though I find one very interesting blog about Open, I'll share with you that how Kubernetes power Open AI infrastructure. It's a very beautiful blog. What I found, I'll share with you. But very quickly, I just want to go through some of few lines here. Okay, so Kubernetes is the one who backbone of OpenAI, and OpenAI, you guys know, the future is generative AI, right? Now we have DeepSeek also. We have many more things coming up. Okay, but core is generative AI, and you guys know ChatGPT and GPT-4. And if you just quickly check, they start on 2017 when they use Kubernetes for some purposes, and scaling, scheduling, thousands of nodes they use behind the scene. Because of Kubernetes, scales very fast. I'm just going very quickly. I just will start in a minute. I just wanted to tell you, okay, how powerful Kubernetes is. They use multi-cluster environment in the OpenAI of the Kubernetes to running a lot of experiments of the what I say of OpenAI or LLM model. 2005 nodes they're using. What is nodes? We'll discuss. Okay, in the older version of OpenAI, I think GPT-4, so GPT-3. Okay, this was kind of setup, and they use HCD network, Flannel overlay network. They use that point in time, and then in 2021, this could be the setup. These many nodes they scale from 2005 to 7,500. And now in GPT-4 or 4.0, I think they use almost 25,000 nodes to create GPT-4.0. Okay, this was a GPT-3 where they're using 75,000 node, and managing 75 individual nodes is not a small game. And it is not only the management of node. Okay, every node has a different setup, different GPUs, different version of the GPUs, different type of GPU, different type of hardware, different type of software requirements. Okay, it's not a small game. Without Kubernetes handling this big setup or infrastructure, okay, and having a proper integration of right tools would be kind of nightmare. Okay, then the journey of 2023, where they come with the GPT 4.0, many other version 4.0 or many other versions are gonna come up, and there they use thousands of NVIDIA A100 GPUs, one of the top GPUs they use, and they do a lot of things in parallelism to train the OpenAI 4.0 model that we use behind the scene ChatGPT at this point in time, and they done it very powerfully. Okay, and without Kubernetes, okay, thing won't work. So this is the example of generative AI or machine learning or the deep learning or the large language model. The point is, whichever domain you go, you need infrastructure and you want someone who manage the infrastructure, especially in the world of where you want to scale. And scale is not the small one. We have to scale in thousands and thousands of systems and node and the computers. Okay, and only scaling is not only the criteria. Okay, we have to integrate with different tools and different devices. Okay, plus we have to monitor also. We have to understand performance. We have to understand the different scenario. We have to understand. We have to maintain the fault tolerance. Any failover, they would be a lot. But just one platform that is called Kubernetes can able to achieve anything and everything, from health checks to automate anything, and many things is there, guys. So don't worry, this is my duty to teach you all of the core component of the Kubernetes. I just wanted to go through this blog. Okay, maybe in some of the part you might not able to understand. That's okay. This is my duty to to explain to you. But I just want to tell you the biggest tool in the market at this point in time, ChatGPT or Open AI tool, GPT-4, 4.0, they are completely rely on Kubernetes, and Kubernetes was or is not there, so it would be hard time for these guys to make their experiment possible and to come up with the LLM tool in the market. Okay, but don't think it is for AI. Kubernetes I'm talking about, it is called any use cases. Anywhere you need something to be completely managed or automated, extremely fast, extremely scalable. Okay, maybe if you just talk about the Pokemon Go, Pokemon Go using Kubernetes. Okay, so they release the largest Kubernetes deploy in somewhere. Okay, it could be any example. Okay, if you go just search how Indian government using Kubernetes, how Hotstar is using Kubernetes, how Netflix is using Kubernetes. Okay, almost every sectors you will find they are using it, right? So I'll start, guys, again from a zero. But before this, I think Preeti introduced me already. But those who by chance does not know me, it is always good to know about your instructor for the day for this training. So my name is Vimal Daga. I just not want to invest much time, but if you search my name in the Google, you can find tons of information about me, what I do, what the different initiative we guys are working on. Right now, we are more into technical training, so LinkedIn can be the one of the resource where you can find something about me. So working from last 22 now 23 years, soon to gonna complete in this industry, work with almost all the top companies in the world, and work on 152 plus technology till date. Okay, one is cloud, one is Kubernetes, one is security, one is Cisco related tools and technology, and cloud, and if you blockchain and AI, LLM. So if you talk about any possible tools and technology I've worked on, and having multiple world record also in different domain in the world of technology. Okay, and having the maximum number of global certificates in my profile, even though my profile is not up to date, updated here, but I have 100 plus global certificate in my account or with me. Okay, so very quick information about me, nothing much. Okay, so let's go and proceed with the Kubernetes. So I'll start, guys, in a way that you guys are new in this world of Kubernetes, so I'll go step by step. Okay, about the Kubernetes. So I just need 20 minutes almost now from now onward to explain you what is Kubernetes and what some of the main component of the Kubernetes. Then we'll go for demo. Then I'll explain some more component. Then we do the next demo. So is keep on managing the concepts and understanding the use cases and the demos also. So thing will be go in parallel and should be very interesting. Okay, so let me start from step by step from very zero. So okay, So let me stop my video streaming. Okay, so you can think in this way, guys. I'm going to start from very zero to make you the things understandable. So you can think in this way. Okay, finally, guys, in the world of digital or in the world of IT, okay, the final thing is why we need IT, because we have some idea, someone has some idea, some has some requirement, and from this idea, okay, they want this idea to be reached to everyone in this world. Okay, they hire some developers and ask them, hey, this is my idea, can you please convert this idea into a program so I can run this program on the computer so everyone can use my program, so my idea can reach to that guy. Okay, so developer, from the basis of this idea, let's say the idea could be social media platform, so someone convert this idea into a software, and it could be a Facebook or Instagram, for example. So developer create an app or the software, same thing, or the program is same thing. And let's say this is a website, so web app they created. Okay, so the app is being created. App is nothing, is a kind of code or program. But writing the program is not uh, enough. Okay, after write the program, we need this program to be run. Okay, and for running the program, what we need one computer. And when I say computer, that means I need one operating system, maybe Linux, for example. And on the top of operating system, we have to put this code, whatever been created by the developer, put this code. Okay, but after put the code does not run, because on the top of to run this code, what we need some kind of environment. For example, this if this code is written in Python, so we need here Python runtime or the Python environment, or maybe many more library which on this code has been written. So after you having your base operating system, after you having some software, Java, Python, C, whatever you need to run this code, then you have to put the code here. And after you put the code, then you can able to run the code. When you run the code, we normally say the use the word that my app has been launched or my app has been deployed. Code is nothing, your app. No, app has been deployed. And after app has been run or deployed or execute, then some of your customer, wherever they are, over the internet or somewhere else, okay, customer or client somehow reach to your app and able to access your app using some internet or using some network. Okay, that's what you guys know already. Okay, but here the main thing is right now if you talk about this particular computer or the machine or the server, okay, who is going to launch this machine, okay, or who is going to install this OS, who is going to set up this OS, who is going to copy the code, technically who is going to run your app. Okay, so it is very common thing in today's world. If you want to launch any OS or this entire setup, this I'm going to use a word called this environment where app is running. Okay, so who is going to launch this environment? So in today's world, we want this OS to be launched very quickly because that's what the demand of DevOps. So one of the DevOps principle is how fast you can do something. It's called rapid. Okay, quickly you can do it means you save a lot of time, and more time you save, more cost you save. That's what we want in this principle DevOps. That's what everyone want. Okay, the game is how faster you can launch this OS, who can install this OS. So here the role of container technology come in play. Okay, because launching the OS, I can launch the OS in my laptop also, but take some hours or maybe a minutes to install the OS. Or I can launch the OS in some of the virtual tool, let's say maybe VirtualBox or any virtualization platform. There also we can launch. Okay, but again, launching the OS or the machines or the computer in this kind of environment will again take a lot of time. Okay, so that is the reason there's a environment, or there's a platform, or I can say the technology called container technology. So with the help of container or containerization technology, we can launch almost any kind of OS, Linux and Windows, and in any environment with pre-set up your Python or Java library. Okay, we can launch within a second or less than a second. It's so cool. You guys might have worked on it, but it is we launch within a second, and that's what we want. The faster you launch, faster you can able to deploy your code, faster client can able to do the business with you. More time you save, more money you save. That's the whole idea. So containerization, and for the containerization is a concept name and technology name. There's one tool available in the market, and many more tools available in the market. One or tool is called Docker that you guys might work on. So Docker is a tool who help you to set up the containerized technology. Or I can say if I want to launch my OS, so I can ask the Docker as a tool and say, Docker, can you please go and launch one computer for me? They will launch very, very quickly. That's the cool part, right? But we have some challenge in the Docker, guys. Those who ever work on Docker, there's one challenge in the Docker. Again, guys, for this training, Docker is not a prerequisite. There's no prerequisite, but I just want to take a reference of the Docker, okay, to tell you some challenge in the Docker. So I would like to show you one small demo. So this is my Linux system running in my local laptop. You don't need this demo to be done. I just want to do this demo to explain you the power what Kubernetes brings to you. Okay, so this is my local Linux machine running in my laptop. Let me launch this. And this is a machine where I have pre-installed Docker. Okay, and with the help of Docker, I am going to launch one OS. Okay, because with the help of Docker is a software that work on this technology, and this technology will launch almost every OS within a second or less than a second. So that is the one demo I would like to show you. That is a powerful part of the Docker. But at the same point in time, there's some challenge in the Docker that also I'm going to show you what challenge Docker has. And to solve those challenges, it's not one challenge, there's many challenges. To solve those challenges or those limitations, I can say, okay, we will bring Kubernetes. So Kubernetes is the one who will help you to solve those challenges. But finally, the key here is, okay, if you want your app to be run, because this is the entire IT world, right? From the idea, you need app development, that is the developer will do, but after developer write your code or develop the app or write a program, you want the app to be run, and for running the app, you need the environment, you need the OS. But who will launch the OS? Okay, so now the favorite tool in the market or the standard tool in the market who launch the OS for you is containerization. So I would like to use this technology. Okay, but in this technology, there's a lot of tool available in the market who help you to launch the OS. One could be Docker. So let me show you one quick demo. Okay, and don't worry if you does not know Docker and if you does not have this system for doing this demo, we don't need actually, because we would like to jump to the Kubernetes very quickly, and I'll show you how to set up the Kubernetes. So again, I would like to repeat, guys, this is the foundation training of Kubernetes. All the main component, all the main concept of Kubernetes with practical and demo, I am going to show you today. Okay, step by step. And also show you how to create your own lab of the Kubernetes so you can practice also. So this is one of my Linux system, and here I have pre-installed Docker. Okay, and what I am going to do, okay, I will tell my Docker, can you show me how many OS is running at this point in time by you or using the container technology? They say no. Okay, so can you do one thing? Docker, I would like to launch the OS, but understand one thing, guys, in wherever you and however you want to launch the OS, For launching any OS, Windows or Linux, you need some bootable DVD that's called image of the OS. You need the OS image. For example, in my case, Windows is running, so I can't install the Windows directly in my laptop. You need Windows DVD or bootable image. Same thing in the container technology also. There is one who will launch the OS for you, but for launching the OS, you need the image. And there's a lot of way to get this image. Okay, there's one site called hub.docker.com where you can find a lot of image of Ubuntu OS or Windows OS or Linux OS or Ubuntu OS or Red Hat OS. But here I have copied my personal image here. If you search for Ubuntu 13 is my account name here that you can also create. And here I uploaded one image. What if this image contain? If this image contain the same thing what I'm talking about. So in this image, okay, image you can like a box or is a bundle. In this image, I put one Linux OS, and on the top of this, I put some runtime, and that's in my case called PHP. I put here, and I put my code. So everything I put together, bundle together, and keep into this image and upload it here, so anyone can download and use it in this image. So I'm asking my Docker to pull this image somewhere with the pull command. So here Docker, we say pull. Vimel 13 is the image name. Name is called Apache Web Server PHP. Apache, just a name, Web Server PHP. Okay, so I'm pulling this image, downloading this image. You can think I'm creating the DVD of the OS, and from the DVD I am going to launch the OS. You can think in this way. Okay, again, this training guide is not about Docker. I'm showing you one demo to just tell you the limitation of the Docker. Okay, so this is the image gonna come up. I can very quickly verify. Does this image downloaded? So yes, this image has been downloaded of some size. Now from this image, I have no OS with me. Okay, and one more very quick term I would like to explain you before we move to the Kubernetes. Whenever you want to launch the OS or install the OS, okay, and if you install the OS using the container technology, okay, then this OS is technically known as container. So we can use the word called we are launching the container. But if you want to launch any OS, the minimum requirement is image. You want OS image. This image either you create and someone created it for you, you can use it. From the image, you will launch a container. So that's what we are going to do. So we have the image that I downloaded. Let me show you. Image we downloaded, but I have no container running. So let me ask Docker, can you please launch or run a new container, okay, or new OS? Run this container in the background, detached mode. Maybe in the future, I want to interact with this terminal. I want a terminal of this container or the OS. And to launch this container, I need an image. So you can take this image, what I downloaded. This image contain base Linux with PHP with some code. And this OS, I'm going to give some name. Let's say this OS1. So this is one command of Docker. If it does not know Docker, that's okay, because this is not my plan, but I just want to show you something. Okay, the power of Docker at this point in time. So what you will see within a second or less than a second, because of the container technology, okay, we are going to launch the OS within a second. Now you can see your entire OS has been launched. In this OS, what you have base OS, some tool like PHP in my case, and maybe some code. And this OS is working fantastically fine. There's no challenge. And now inside this OS, the way I create this image, I have a PHP app, and this app is running fine. How I know? Because there's no error, but we can connect. So every OS has the IP address. So I can use Docker and say, Docker inspect. Can you tell me the IP of this guy, OS1? Can you show me the IP of this OS so I can connect? So IP in my case is 2, and at the IP2, that is IP of this OS. My app is running. So what I can do, I can open my browser and to see how app is working and what is look and feel of my app. Of my app. So what you will find, my app is working fine, and whatever I put in my PHP code or PHP app, you will visible here. Okay. Now, in this entire journey, okay, so the app is running with HTTP colon slash slash 172.10.0.2 is the IP of my container. Okay, if I hit enter, you can see app is coming up. And by chance in my app, I just put the aqua color and I welcome to Vimal web server. Okay, and plus I also print the IP of my OS. So you can see this IP of my container is also printed. Same IP because I connect to same container. The app is working fine. Okay, nothing beautiful, but this is a kind of demo app I put. But here, this is thing you might know. If you does not know, I explained to you very, very quickly. Okay, but the beautiful thing is, uh, Docker or the content technology can launch the entire setup or the environment or the OS less than a second. That is a beautiful part of the container. And to use the container technology, we can use one of the tool called Docker, or maybe you can use Cryo. Maybe you can use Podman. There's many tool available in the market. In my case, I use Docker. This is what I use by this command. So till here, everything looks fantastic. There's no challenge. Okay, and Docker is doing very well. Within a second or less than a second, they launch the entire OS from some DVD or from the OS, from the image. Looks pretty powerful. That's what the power of Docker. But we have one challenge here. Okay, the challenge is right now I'm running with the OS, this called container. Okay, and there's no guarantee, guys. Okay, any OS can bring down or terminate it or fail at any point in time. Any point in time. For example, I'm doing it manually. Okay, so there's Docker command, Docker. I can want to terminate this OS. This could remove this OS forcefully. Okay, I'm doing it manually, intentionally. But let's say it is done unintentionally at the XYZ reason. Maybe your hardware failed, maybe your RAM has been exhausted, maybe a certain load gonna come up, we have bug in the code. It could be any reason. Your OS can terminate. And as soon as the OS terminate, okay, because app is running on the top of the OS, if OS terminate, the app is also shut down. And if app is shut down, then your client won't able to access the app. You can see here, if you refresh, your client is won't able to access the app. See here, they're disconnected. Okay, it means you have a downtime. Okay, that means it's not just a term downtime. Okay, it's not a term fail or just a downtime. That means we have a huge loss in the business. The final game is the business. Whichever company you guys are working on, or you have your own company as a startup, does not matter. The main thing is your idea should reach to a client, and the only way to reach to the client in this world is app. If app is down, that you have a huge business loss plus the reputation loss. Every minute you guys are earning from the clients. Okay, so we can't take any risk that any point in time my app goes down, because it will give you the loss in the terms of money, obviously, but it's also give you a loss in the terms of reputation. For example, your online match is going on, maybe World Cup cricket, and you're watching on the Hotstar, and where the app is running on the Hotstar, if the OS goes down, then you can't able to watch the match, right? And obviously, in this case, you have a bad experience from the Hotstar. So in that next go, you will never go to Hotstar to watch the match. It's a huge business loss and the reputation loss for the future. Okay, so in this case, what we can do, pretty simple, because Docker is super fast. Super fast. Again, I can ask the Docker, can you please rerun this command? And because now here the power of container come in play, as soon as something goes down, okay, we can run it again. And as soon as run, your OS started. Within a second, your site is up. Fantastic, right? This is the power of container. Why we want something very cool and very fast? Because something goes down, something goes down, it will come up within a second or less than a second. Okay, but here we have one challenge. The challenge is when your site goes down, okay, who launched this site again? We as a human being. So I as a human being, let's my name Vimal, okay, I have to keep on monitoring that my site is goes down, and as soon as it goes down, I have to type this command and relaunch it. So it is more like a manual thing. So they launch within a second. That's cool part, but to launch, we as a human being is to do two things continuously. We have to keep on monitoring. Hey, you are down or you're up. You're down or up. And if it's down, then we can go and launch again, run again, Docker run. And here we are doing everything manually. But challenge, guys, here. The challenge here is, okay, anything whatever we do manual is a challenge. Why? Because we are lazy. Human beings are lazy, and second thing, we do the things very slow. And time is the game here, right? As soon as you go down, maybe they go down at night 3 o'clock, and maybe you're not up that point in time. After some second, you come to know. After some minute, you come to know site is down. Then you go and tap the command very quickly in your server, because we can't monitor every time, every second. Even though we monitor every second, that's not possible for the human being. But if you monitor every second, then typing this command, running this command take 1 or 2 seconds. In some second, maybe 10 seconds or 1 minute or 2 minutes, your site is down. That is also a big business loss, right? Today, every company want their site or their app is always up almost 100%. That's what everyone trying. And almost nowadays, almost every company reached to 99.9999% uptime. Almost every top company. Okay, and everyone now is struggle to get 100% uptime. So right now, Gartner has come up with the entire plan and strategy how any company can reach 100% uptime. So they have give a lot of guidelines to you. But for this, in this case, why you want to have uptime? I think you understood. This is because of the company reputation and the business. If site is down, there's no business. That's obvious. Okay, but to make it up, okay, we can't use any manual way. We want everything to be automated. We have to remove the human being from that process. And if the human being is not doing, the who will do? Obviously, computers will do. And the computer guys who will do, program will do. So we need certain program who do this part for you. What they do, they keep on monitoring for you, and as soon they find something is not working, something fail, they launch it again, fail over. That's what they do. Okay, and good thing about the computer is and the program is they run on the top of computer. They work 24 hours and 7. They are not logy. They don't do any mistake. Whatever we ask them, they do as it is as same, and they do very very quickly with the speed of light, maybe. Okay, so in this use case, what I was talking about. Okay, as soon as your container OS goes down, right now is working fine. As it goes down, okay, we want not the human being. Let's say it goes down some reason. It goes down for some reason. So we don't want human being keep on monitoring, and as soon as they goes down, okay, goes down, then human being come and type this command and then some script maybe for for launching and they up. I don't want to. I want as soon my OS goes down, my some program in the computers keep on monitoring this part, and as soon as it goes down, they notice within a second or millisecond, and as soon as it goes down, they make it up for you automatically. That's what we want. Okay, and for this we need some program, and here the role of program that help you to achieve this is called Kubernetes. And Kubernetes is not the only program in the market. We have many more competitors of the Kubernetes also. One is called Docker Swarm, Docker Docker has own tool called Docker Swarm you can use. You can use Mesos, Marathon, and many more tools you can find. These are the kind of competitor of the Kubernetes, but the main share in the market, almost 90%, 95%, and more than 90% is to Kubernetes. Why? Because they have a lot many features in the facility and many more things. If you go ahead, I will discuss many things about the Kubernetes. Okay, Kubernetes for you. So what I can do, I can tell my Kubernetes, hey, can you please keep on monitoring my container? Okay, and as soon as you monitor, if something goes down, okay, you can make it up again, and it to be done automatically. And that this is one of the use of Kubernetes. I'm not saying this is the main use. This is one of the use of the Kubernetes. Kubernetes can perform for you. So I'll show you in a demo. After some time, when we bring the Kubernetes in a minute, okay, I'll do the same demo and I'll show you as soon as it goes down. Okay, Kubernetes will automatically make it up, and we as a human being don't have to do anything. Anything. Okay, this is one thing. But understand one thing. Okay, technically, when I say Kubernetes is the one, he is doing something for you guys. We can also write Kubernetes in one more way. This short name of Kubernetes, K. If you count 1, 2, 3, 4, 5, 6, 7, 8, we write 8 and S. So this is also the short form of the Kubernetes. You can say write this or this is same thing. So Kubernetes is a software, is a tool. Okay, and if you go to this side, Kubernetes is a tool, okay, used by almost every company in this world. And this tool, okay, and it is helping you in automatic and many more things they do for you. This tool has been incubated by Google. Then after the Google, they they make it open source. They provide to CNCF community. They have that. Okay, and this tool is so powerful. They design in such a way that Google also using Kubernetes behind the scene. And in a week, they are managing billions of content. That is a power, not thousands and millions, billions of container you guys can scale. And some of the biggest use cases, huge traffic system, maybe Netflix and some many advanced testing scenario, we might need millions and billions of container. That's what level of scale Kubernetes can make. Right now, I'm just talking about one container, just one container. Okay, but billions of container Kubernetes can manage. Now it's open source tool, but this is how it started from Google. Now, the main thing to understand is, okay, if you ask Kubernetes, who are you? I'd say I'm a software, nothing, just a software. But can you launch a container for me? Can you able to launch a container for me? They say no. I don't know how to launch. Before launching the container, okay, we need an image. There's one thing. But to launching the container, we need some container engine. Container engine. Engine, you can think if you have a Python code, you can't run the Python code. To run the Python code, you need Python runtime or Python interpreter. Similarly, to run the container, we need container runtime or container engine. This is a kind of program who are able to launch the container for you, install the container for you. Okay, and one of the program who can give the container engine are Docker or Cryo or Podman or Rocker, or maybe many more. So Docker are the product who give you the container engine. I'm not saying Docker is a container engine. There's myth in the market. Okay, so Docker is not the container engine. Docker is the one who give you the container engine by some program called runc. So what it is, that is not important to know right now, but that's how. But let's say for the sake of understanding, Docker is a container engine. Okay, and Docker will help you to launch the container. That's what you can see. We can take the help of Docker to launch the container. Okay, but if you ask Kubernetes, hey Kubernetes, are you a container engine or container runtime? They say no. Okay, I don't know how to launch the container because I am not the container runtime. I am not the container engine. I don't have no idea how to launch it. What we can do, what I can do for you, okay, what I can do for you, you can take one computer here, one computer here, sorry, one computer here. In this computer, okay, let's say in this computer, you can take one operating system, maybe let's say Red Hat version 8 or 9. And on the top of this, you can install one container engine. Let's say it could be Docker engine that you can install. And what Docker can do, okay, Docker will go and take the image from somewhere, mostly let's say Docker Hub. Okay, they go to this site, the way I explained to you right now. They go to this site, download some image, and after they download the image, okay, they launch a container. And by the way, guys, this computer is a real computer, and computer, guys, in this world is also known as node. So we'll ask my Kubernetes, keep on watching the node A. Let's check how Docker engine is working. For example, if Docker has launched one container, and due to XYZ reason, if this container goes down, so Docker has no idea and no way as such. If something goes down, so Docker does not go and launch the container for you automatically. That's what the demo I showed you. But what you can do, Kubernetes, you just do two things here. You keep on monitoring, you keep on monitoring this particular container, whatever we launch, where my app is running. So this is called app container. Keep on monitoring this guy. And if this goes down, okay, now it is your duty to launch it again. Okay, that's what you do. But because you are not the container engine, so you does not know how to relaunch. So behind the scene, your duty is to keep on monitoring. Hey, are you goes down? Are you goes down? If no, do nothing. But as soon as it goes down, you will go behind the scene, contact to Docker engine, ask this guy, hey, something goes down. I am asking you to relaunch it. It is more exactly what we have done manually. So we, let's say our Kubernetes, I keep on monitoring, I keep on monitoring, I keep on monitoring. And as soon as I found, let's say I am a Kubernetes, I found this goes down. And as soon as it goes down, because I'm Kubernetes, I keep on monitoring within a second, less than a second, I ask my Docker, can you please go and launch a container for me? So Kubernetes asks Docker to run this Docker command and launch the container for you. So side will be kind of always up. Okay, so this is what Kubernetes do for you. So first of all, Kubernetes is not a container engine. They are not the one who launch the container for you. They take the help of container engines or Docker engine launch the container. This is one of the things Kubernetes can do for you. And that is a reason Kubernetes is known as management tool. They are the container management tool. They manage the container. And if I talk of management, so there were many things, guys, in the world of management gonna come up. Okay, it could be security, it could be monitoring, it could be storage, it could be networking, many things gonna come. It's a big world altogether to be understood in the world of management. I'm just talking a very small peanut as just to give you some concept of the Kubernetes. But as we go ahead, we'll see there will be many component to be discussed. Okay, but in this example, we have again some more challenge we have. Some more challenge we have. So what is challenge? Let me recreate one more diagram. Okay, there's a possibility because you guys might know. Okay, if you want to launch the container, launch a container with the Docker, you need Docker software. But to run the Docker software, you need some base OS. In my case, Red Hat. And this base OS should be running somewhere. In my case, it is running in my Oracle VirtualBox, or in your case, it could be running directly in your laptop. It could be running in the cloud, AWS or Azure. So this is a base OS where my Docker is running, and this base OS is also known as node or the Docker host, whatever say the same thing. Okay, so let's say I am running with the Docker host or the node, one minute, Docker node or the host. So let me say this is the node I'm running with. Okay, and the setup will be kind of always like this. On the top of this computer has, or I can say host, okay, or Docker host, whatever a container. So let's say on the top of this, we launch one container with the help of Docker engine. But obviously for launching, we obviously need image. So they download the image and then they launch. Who download the image? Docker. Okay, this is how it works. But this is the only Docker. But what we need, we want Kubernetes, the way I explained to you. So we have one computer where Kubernetes program is running. And these guys keep on monitoring this Docker node, let's say node number 8. And what they're monitoring? They are monitoring this container is up or not. But as soon as the container goes down, okay, the Kubernetes will make this happen automatically. As soon as the goes down, something fail, so Kubernetes will relaunch for you this container automatically. You don't need to do anything. They relaunch. Something fail happen, they will fail over. I don't use the word fail over, but something terminated, they recreate for you. That's what the Kubernetes do automatically. But the challenge is to launching this container. We need Docker engine. For the Docker engine, what we need base OS, and for base OS we need hardware. But what happened? Okay, if your hardware fail, if your physical hardware fail, if your OS fail, your Docker engine fail. So that is not the responsibility of the Kubernetes. Kubernetes is only meant for managing the container. Kubernetes is not meant for managing your OS or your hardware. That's called physical resources. They're not meant for to managing the node. And node, guys, is what they give you RAM and CPU, and anyone who give RAM and CPU, that's called infrastructure. So Kubernetes is not meant to manage the infrastructure. So infrastructure is normally managed by your tool like Oracle VirtualBox in my case, or maybe AWS Cloud if you're running in the cloud. So they have their own way to manage the infrastructure. Okay, so let's say this OS is running not here, they are running in the cloud somewhere. Let's say in the cloud, AWS cloud. So in the AWS cloud, I'll go and launch this OS in the cloud. So this is the responsibility of the cloud to provide all the stuff there, almost all the stuff, for example. Okay, and then on the top of this, we launch a container. But managing the container, again, we can use Kubernetes. But by chance, if this particular part fail or terminate, let's say your physical hardware fail. If as soon as your physical hardware fail, okay, your entire OS goes down. If OS goes down, so container is running inside the OS, so container is also goes down. There's no node, so Kubernetes is kind of disconnect with this guy. The Kubernetes is not able to further manage these guys. They're not able to do anything. So in this case, what we can do, what we can do in this case, okay, we have to use better practices, and the better practices or the best practices what we can use here. Okay, instead we use one node. We can use one node. We can take one more node. There is a plan of our strategy or our plan. So we can take one more node, or we can take one more independent node. Node means like an independent laptop or independent computer. Now it is your choice. These computers can be running in AWS cloud, can be running in Azure cloud, GCP cloud, running in on-premises or local laptop. It will be your choice. Wherever you would like to run, they have no challenge as such. Okay, so let's say they're running in the AWS cloud. All these guys, there's an independent computer. So when I say independent computer, I mean to say everyone has their own physical hardware. Everyone has own operating system, maybe Red Hat version 8 or Ubuntu or something like this. But they should have Docker engine or container engine. Same thing here. So now I can say these are we have multiple node. We have now node A, node B, node C. Okay, so in our case we have 3 node running with the Docker engine or container engine. Now we can tell my Kubernetes, now you don't need to manage one guy, you need to manage, in this case, 3 guys together. I'm giving you 3 node. And the benefit is why we're giving you 3 node, because there's a possibility, there's a lot of things we might need, why we need 3 nodes. There's a possibility, okay, that we are running one container here in the node A. If this container goes down, you can relaunch again. That's what I'll show you demo in a minute. That you can do. You can do. But if the entire node goes down, so there's no way to launch the container because the system is shut down. How can you launch? The system shut down. How can you launch? So in this case, what you can do, by chance, if this container goes down, so you know there's one more node B is running, same container you can launch in B. So that is one of the reasons why we need multiple nodes. Because at any point in time, your hardware can fail. At any point in time, your system goes down, network disconnected, any kind of fail happen, or any kind of fault happen. And if you want to tolerate the fault, let's go fault tolerance. Many things we require, but one of the things here, it helps us to tolerate the fault. That if the entire system goes down or crash, how we can tolerate this? How can we make it happen again? Okay, so we can give multiple computers to nodes to Kubernetes and say B and C is there, so you can please take this container. Again, we have the image somewhere in the Docker Hub. Take this image and launch the container here. Same container. Okay, that's what they can do. And the beautiful thing what Kubernetes can do for you, because you guys know, container is running with your app, and app has their own URL or the IP address or the network connectivity. That's what the client, let's say I'm a client, I connected to this guy. Okay, to this guy. Now, Kubernetes also give one more facility. Okay, let's say my client is sitting somewhere here over the internet. Initially, client is connected to this container using some network. Okay, and this network is because this container running in this OS, so they're connecting to this OS and to this container. Okay, but by chance the entire system goes down. Okay, if entire system goes down, the network also goes down. There's no network for the connectivity. So Kubernetes do main thing behind the scene. What they do, they launch new container, new computer. New computer has their own networking, own network wires, own different way of network connected. But Kubernetes behind the scene works seamlessly without any human intervention. Okay, they first launch this container for you. And after they launch this container, behind the scene, they send the, or I can reroute the traffic to the new content into the new computer automatically. Means the client perspective, if client perspective, they keep on refreshing, keep watching. Behind the scene, you think it is working, you think you're connected to first kind of a behind the scene kind of field. They launch a very different computer somewhere else, but the client has no kind of fail happen, no kind of disconnection in any form. My app is keep on working and behind the scene, but they reroute or reset the entire network connectivity to the different computer. It's completely done by the Kubernetes automatically. How, we will discuss in detail, but this is one of the cool things Kubernetes can do for you. Can do for you, and many more things also on the top of this. Okay, I mean, how they do, we will discuss. That easy reason, guys. We mostly use this term, and mostly what we do whenever we launch a Kubernetes, we don't give one node to a Kubernetes, we give multiple node to the Kubernetes, and with all this node help us to manage many things. Something fold happened, they tolerate the fold, and many more things they help us. Okay, so this what is a very common setup we see. And if you talk about right now, this is just a 3 node. If you talk about OpenAI use case that I was talking about, okay, OpenAI use case. So in GPT-3, I'm talking about, in GPT-3 version, the old version. Okay, so in GPT-3, they are running not 1 or 3 node. In GPT-3, they are running with 7,500 nodes. That is completely managed by Kubernetes. They are running with 7,500 node running behind the scene. Managing these many node or the computers is not a small game. I can think in this way. For example, OpenAI in AI world, OpenAI in the world of LLM, like say ChatGPT. Okay, so they does not want to manage the infrastructure, right? Their focus area would be what? The work on AI. They want to do a lot of experiments, a lot of testing, training, many more things they want to do. So they don't want to invest their time how to manage the node. If something network goes down, okay, how to disconnect and reconnect the network. If something fails, because out of 7,500 computers, any computer can fail, any computer goes down, hardware fail, network fail, electricity goes, some part of the computers. So they does not want to do any kind of these management. That's called network management. So infrastructure management. Okay, because their goal is what? They have an idea. They want to create a chat GPT. That was the idea, or LLM model, or generative AI. So they want to focus on that part. They does not want to invest their money and time in managing the infrastructure. So what they have done, they have given the entire responsibility to Kubernetes and say, hey, we are handed over to you 7,500 computers in GPT-3, 4 we have them many more. Okay, computers or the node. Now you will handle. I does not want to handle. Okay, because in my container, in my container is OS. I am running with my program. This in this case, machine learning or deep learning program. I'm doing some experiment. I'm doing some testing. I'm doing some training. Whatever they're doing, that's not very important here. But I'm doing something in this container. But whatever is going on, if due to some reason, if this entire container goes down, so I don't want to invest my time to launch this container. Okay, you will go, keep on watching, something happen, you will go and launch the container. And what I was doing here, you will continue from here, from there. That you do as a Kubernetes. And wherever the container is running, if the entire system goes down, okay, you will go and figure out which node is available and which node is free also. Because there's possibility node C running with lots of content, because in one computer we can run multiple container also. Okay, for example, content is managed by Docker engine or any engine, so we can run many more. For example, I can launch one more OS. Why not? So in one computer node, we can launch many containers. Okay, but these containers will take this OS, right? So they will take the RAM, CPU from a base OS. This is a base OS. So in this base OS, if I run the count of free have an M, this will tell you how many RAM you have. So in this base OS, I have around 2 GB RAM. So this 2 GB RAM has been shared to all the containers. So container take the RAM, CPU, all the things from base system. So for example, here if node C are running container 1, container 2, container 3. But in node C, we have a RAM memory of let's say 4 GB. So 4 GB has been shared to all the containers. So maybe this container taking 1 GB RAM, this taking 2 GB RAM, this taking 1 GB RAM. Entire RAM has been consumed. Now there is no RAM available. And because there is no RAM available, if you try to launch one more container, it might not work. Means node C is completely fully utilized. Who know this? I can monitor, right? 4,500 computer, which is free, which is utilized, which is right now available for us. Okay, we can't check as a human being. So we can tell the Kubernetes, one of my computer goes down, we are running a container of machine learning or deep learning, something is going on, some experiment is going on. Okay, if something goes down, my experiment fail. fail. So you go and figure out which node out of 7,500, let's say node number D is free. Okay, so you will go and launch the container there. Container there. So if this goes down or the entire node goes down, you will go and launch the machine learning app there or container there. Okay, if you think I'm talking just about the management part, right? This is what management required, right? The big environment, high scalable environment, 7,500 or maybe in GPT-4 or 4.0, or they use almost, I think, 25,000 nodes set up. Okay, so we can't do management. If you doing the management by yourself, or maybe you can create your own tool in doing the management, it would be hard time. Why? Because we are not into infrastructure, right? We are the app developers, we are the machine learning guys, we are the live streaming like Netflix and Hotstar medium. So why to invest our time and money on doing something that we are not meant for? meant for. So let's bring Kubernetes, and they will do this part, and they are very well, because the way the Kubernetes has been created, that I told you, okay, they have created in a way they can handle billions of containers, not single, millions of containers. And this is the container I'm talking about, C1, C2, C3. And they can handle, not container, they can handle thousands and thousands of node also. Node A, B, C, D, D. For example, in GPT-3, they're handling 7,500 nodes. Are working very well. Okay, so in this case, you can use some terminology. The computer where Kubernetes is working is a software. There's also a computer having also have RAM and OS. This computer are known as manager computer or manager node. So let me create one more quick diagram to give you some vocabularies. Okay, so in the world of Kubernetes, the minimum requirement is we obviously is a software. We need to run the software. So wherever the Kubernetes software is running, then this node is known as manager node. Sometimes we also use the word master node because they're managing all the computers. They're giving the instruction to other computers. And the computers where you are running Docker engine or any container engine, any container engine, okay, where you are running your container, because they are the one who are working for you. So those are known as worker node. sometimes also known as slave node. Okay, so this is a computer where we are running the containers, one or many containers here. And why can we can able to run the container? Because this is the computer we are running with the engine. This is container engine, let's say Docker engine. So we can launch. They're working for us. And because they're working for us, anything who work in the computer also have compute. So we can say compute node. So when I say compute node, slave node, worker node, same. Okay, and these are not the major node, master node, because they're controlling. So they're also known as controller node. Control node. Okay, and sometimes also we use the word instead of node, we also use the word called plane. So this is called control or controller plane. So multiple name you have, whatever you say, same. So one plane, one area where they control is like control tower, controlling all the planes, something like this. And these are plane 1, plane 2, plane 3. Okay, and here, okay, these guys together. Okay, so this master node connect to all the slave node and ask them to work. And this is a pretty intense system. They know what is going on in all the node. Which is node is up, which node is down, which node, how many container running, how much RAM and CPU they used. Okay, how much traffic is coming. Many things they they know, and because they have entire that's called visibility across all the computers, all the node, so they can do a lot of decisions on the top of this. And with the help of decisions, we can do very interesting tasks. What are tasks? We'll discuss. Okay, so here all the master node or the slave node work together as a team, and this team is called cluster. And that is the reason we can show this called container cluster. So with the help of Kubernetes, we can create a container cluster where Kubernetes will keep on watching this container. If there's something fail, this also not fail. There's also possibility this computer having a 4 GB RAM, and by chance this container need, hey, I need 5 GB RAM. Maybe some lot of tasks or lot of load coming from the customers. So we have not many RAM available, device available. So this container, my Kubernetes will keep on watching, and they remove from here and they launch here. Because they know behind the scene, this computer have 8 GB RAM available. Because they have entire visibility what is going on, what are the resources we have and available. So they launch here, relaunch here. So all the things done automatically. You don't need to do anything. I'm just trying to tell you what they do for you in terms of automation. Okay, these are many example or many more example I'll show you. They do for you. Okay, and that is reason we normally use the word. Okay, Kubernetes is the one who orchestrate. You know, orchestra. So one guy manage many guys in orchestra. So Kubernetes is a orchestration engine. This called container orchestration engine. This is called COE. So Kubernetes is a COE tool actually. So you can use Kubernetes is a cluster tool or COA tool. Is a multiple name we use in the market. Whatever name you would actually use, you guys can use. And here, guys, because we have more than one computer, so it's called multi-node cluster. So mostly in the world of Kubernetes, we use multi-node cluster. Okay, and cool thing is Kubernetes open source. It is also free. Free, so you can because open source is a software, you can install Kubernetes in your labs, in your laptops, in your setup, and run it. There will be no charge, there will be no license. You can use in your way. Okay, only thing you have to set up, and that's what we will learn how to set up the Kubernetes. Okay, but again, let me go back to this block. So OpenAI here, the node 1, node 2, this become a cluster. This is what I was talking about. So Kubernetes create a cluster. create a cluster. And the one term I want to use here. Okay, maybe right now they're running 4 node, and every node have some RAM and CPUs. So maybe they they want to launch more containers. Containers are the one who run the the app for you, and app is the one who do something for you. So that is the reason we use the word called workload. So sometimes we also use the word called workload. So we have to do many workload. Okay, and maybe at 4 node at this point in time, this is 8 GB RAM, this is 4 GB RAM, this is a let's say 12 GB RAM. So these many resources or physical devices is not enough. So we can add more computer. So on the fly, on the working cluster, we can keep on adding more and more and more real computers. Okay, and more computer add more and more cluster size increase. More and more cluster will have more resources. When I say about resources, I mean to say mostly physical resources like RAM and CPU and many more things. Okay, and this concept, guys, is called scaling. So we can scale the nodes. Okay, and because we're scaling multiple computer, we're adding one computer and second computer, third computer, and then this kind of scaling is known as horizontal scaling. Horizontal scaling. And the word horizontal scaling, adding more computers. Okay, if you add and add and add, this is called scale out. And maybe there's a real computer, maybe come with some price and cost if you run in the cloud, let's say, per hourly, per minute basis. If it does not need, you can remove on the fly. Okay. Why? Because you want to save the money. Because this computer, if you want to launch, you have to give electricity. You do launch in the cloud. Cloud will charge you per hourly basis. If you don't need those resources, you can remove. And any container what is running here, as you remove, the computer will relaunch here. Okay. Then they can remove the computer to save the money and make other things. It's called scaling. So we can do scale in and scale out very quickly. Okay, without any further hurdle. Okay, that's what we can do. So this is what they are using the word scale up. Scale up is a wrong term. I don't know why they use scale up, has a different meaning. A lot of guys use the wrong term. This is wrong. Technically here they are trying to say scale out. That's called scaling, horizontal scaling. Okay, so that's what we can do here. So you can see a worker node 1, 1, 2, 3, 4 worker node. And what you see, guys, here, this entire setup is the internal of Kubernetes. Okay, so this entire diagram from load balance and this green blue color, what you see here, control plane, this is inside the Kubernetes. Here. So 1 minute here. So when I go inside this box, this control plane, I will explain this terminology to you. The Kubernetes is doing lots of things behind the scene. So some of the things you can see here: API, control manager, HCD, schedulers, control plane node, load balancer. So that's what we explore in a minute. When I go inside this box, this called master node or control plane. I'm just trying to give you the outside layer, what is happening, and then some of the terminology here. Okay. So I think now you will discuss in a minute. Now you understood. One more term I want to give you here. Okay. If we just use any container engine like Docker, so in the world of Docker, your OS is known as container. But if you launch this container, okay, you can use this command. But right now I am running this command. So I'm a human being. I'm running this command. I'm launching the container by myself. Means we as a human being is managing the container launching or something else also. But same command, if run by Kubernetes, it means first of all, you don't need to know the Docker command. If you're asking Kubernetes will go and manage, so Kubernetes will go and run this command for you. It means if you don't know anything about Docker, that's okay. But everything, whatever you see here, is been run by Kubernetes or managed by Kubernetes. So first of all, you don't need to run this command or know this command. Okay. So that means if it does not know Podman, Cryo, or Docker, that's okay, because we does not go inside the worker node. The Kubernetes from the master node is going to manage everything for you. This is one thing. Okay. Second thing, in the world of Kubernetes, when they will contact the Docker and ask the Docker to launch the container, okay. So in the world of Kubernetes, we don't use the word container. You can use if you want, but in the world of container, so in the world of Kubernetes, this container is been managed by a term, or I can use right to make it simple. In the world of Kubernetes, this container is known as pod. So for some time, okay, because right now we just started this training, for some time you can think pod is exactly equals to container, and container is exactly equals to your operating system where app is running. Okay, so exactly equal is not right. Actually, there's a small difference that I will explain you in some time. But right now, for because we just started, think when I use the word pod, I am trying to tell you it is a container. It is a container. That's what you can you can think. Okay, at this point in time. So guys, this is a some few concept. Okay, so in this right now, guys, because we just started, or in this foundation training, we are not launching the multi node cluster, because it will take some 2 or 3 hours to launch this entire setup. So all the demonstration of Kubernetes we can do in single node cluster also. Because if you want to learn the Kubernetes and learn the component like pod example, and I want to see if pod goes down, container goes down, the relaunch automate for you, and how to connect. I can hold for a second, please. Okay, so yeah, so what I'm talking about, if you want to learn the Kubernetes, Kubernetes had lot many vocabulary gonna come up. Pod right now we're discussing, then we will discuss about Kubernetes multiple different vocabulary like API and scheduler, HCD, load balancers or service, many other things also. Okay, so right now we have to first learn this vocabulary by doing demos, practical. Okay, but for doing this demo, we don't need to first set up the multi-node cluster. Okay, because setting multi-node cluster will take some time. So those who are a part of my TGS program that is happening in multiple cities like Bengaluru and Hyderabad and Pune and Gurgaon. Okay, so where we are doing this Kubernetes training offline. So we will do the setup there, or anyone who is part of my DevOps specialized program, we also do the setup there. Because today we is a 7 hour we dedicated for Kubernetes. I don't want to invest this time at this for doing only this setup. Before doing this entire setup, it take multi-node cluster setup will take will take almost 2 to 3 hours. Okay, to but to quickly jump into Kubernetes world for doing the Kubernetes learning and their internal components and practicals. Okay, what we are doing, we are only launching one single node. So same node will work as a master node, and same node will work as a worker node. That's also possible. There's a single node cluster. That's what we are bringing at this point in time. Only my intention is only my intention is okay, is to show you Kubernetes concept with practical. And to launching this setup won't take much time. Very quickly, within a minute or 5 minutes, this setup will be up, so that we can quickly do the demo. Demo would be the same. Almost whatever you can do in single node cluster, same thing we can do in multi-node. Almost same, not, but there's some maybe advanced thing that can only work in multi-node cluster. So right now we are not into advanced training of Kubernetes. Today we plan for core or fundamental training of Kubernetes. So whatever we need today is enough to work on single node cluster. So there's a plan. Okay, and we have many more vocabulary, guys, to be discussed. Okay, so we'll discuss in a minute. But before this, let's bring the Kubernetes first. So inside the Kubernetes, when the Kubernetes is going to come up, I can show you the vocabulary. But I want to give you one task to everyone. Okay, so from our side, it is a kind of compulsory task. And the task is right now what I am doing at this point in time to you. I'm sharing lots of knowledge. So with the minimum time I can share, I'm trying to share as much as knowledge, practical concepts, and different use cases to you in just in today, in one day. That's my responsibility to share to you. And your responsibility is to share to everyone across the world. Okay, so what you have to do, okay, just pick one of the company case study. Let's OpenAI, or or maybe let's say Pokemon Go, or let's say how Hotstar or Netflix or Uber or bank and NASA. Okay, how, or maybe Indian government, some sites, how they are using Kubernetes, why they are using Kubernetes, what kind of benefit, ROI benefits in the forms of any of the anything they are getting from the Kubernetes. So read some document. You can search based upon your interest on the product and the company. Search, you can find a lot of case study. Maybe some of the case study you can find here also. See here, Kubernetes IO case study, or you can search in Google, booking.com, and many more you can find in many other area. Box they're using, there are many company, booking.com, Boss, IBM, and you can find, or you can find many other way also. Read one of the case study, how Spotify using it, what the benefit they're getting it out of this, guys. And those create one blog or the post and share it in LinkedIn and Medium, whatever you feel like. Okay, so everyone come to know the use cases and the power of the Kubernetes tool, so they can use somewhere in your in their requirement. Okay, so I suggest share this. Okay, and beginning is a kind of compulsory task, because we will, after this foundation training, we will give you a certificate also. But for the certificate, you have to attend the entire training. Okay, to get a certificate from our side that you complete this training of Kubernetes. But to achieve the certificate, you have to do multiple things. One, you have to attend the entire training, obviously. I mean, you have to learn, that is a core concept requirement. And then you have to do some task, practicals. I will show you what task and practical you have to do. Okay, and then you have to also share some case study. You also learn a lot. And you can see we have almost 500, 400 plus student candidate here. So many case study gonna there's so many learning we can do from each other. You can think, just everyone invest some time, make curate the case study in the best possible way. Okay, and whoever come with the best possible way in creating the story or the case study or the post. Okay, we will also pick some of the top few participants here, and we will also reward you by some reward or goodies, something like this. So our team will announce soon in some days who will be the best one who put the case studies. Okay, so it'll take one day maybe to complete this task. After you doing so, they will reward you with the case study. My team will again rewrite this requirement from our side, what you need to do after my training complete today. Okay, let's try to do this. The main goal is is to share the knowledge. That's the main goal. Okay. So let's do the setup there. But before this, I just want to tell you one more small thing, very quick thing. Kubernetes is a software. Is a software. We can also write in this way. Cube is software. Okay. And to set up this software, okay, there's two way we can set up the software. One, we can set up the software in our own hardware that is been purchased by you or by your company. This is called on premises. Maybe you can use the private world. Or you can install the software that is been hardware you will take on lease on rent. That's called cloud providers. It's called public world. So you can install Kubernetes anywhere, wherever you want. Okay. Second thing, Kubernetes is very kind of product that almost everyone use. So what this cloud guy has done, they say now if you want to set up, because we use multi-node cluster everywhere. Okay, so rather than you set up the multi-node cluster by yourself, we are giving you some services in the cloud. Let's go cloud services. Okay, and you can use our services where we will give you sorry, we will give you a pre created, or I can say we will help you to set up this entire multi-node cluster in the automated way. So technically, you don't need to do the multi-node setup by yourself. The cloud will give you a services. Click on button and they will set up for you. For example, if you go for AWS cloud, they have a service known as EKS you can use. If you go to GCP cloud, Google cloud, they have a service called GK, Google Kubernetes Engine. This is Elastic Kubernetes Services. If you go for Azure cloud, Microsoft, they have a service called AKS, Azure Kubernetes Services. If you go to other cloud, they have other services also. Also, if you go for on-premise, may on personal data center or lab, okay, again we have multiple way. We can also create on private cloud also, if you guys might know. So one of the private cloud software in the market is called OpenShift or OpenStack also. But if you talk about OpenShift, we can OpenShift also from Red Hat. So if you know that OpenShift is nothing is a Kubernetes. So OpenShift is completely working on the top of Kubernetes. So that is the reason anyone who is planning to learn the OpenShift, the prerequisite is Kubernetes. Without Kubernetes, you won't be able to learn the OpenShift as a tool. It's also have a huge requirement in the market. Okay, so behind the OpenShift, they are running Kubernetes. So whatever we do in the Kubernetes is the same what you do in the whatever you do in the OpenShift, same thing you do in the Kubernetes. So these are tools or platform, I can say, public or private cloud platforms. But we don't need cloud. We can also install Kubernetes by launching multiple computers. So if you want to launch multiple computer, means you are planning to launch multi-cluster setup, or you want to launch only one single cluster. So we also have a tool available in the market. So there's one more tool, very powerful tool, where we can set up our own personal setup, especially the multi-node cluster. That I think that is what many company might use. So there's a tool called KubeADM that we can use. But if you're looking for single node cluster, that is what we are going to set up right now, just for quick learning. When slowly, those who are part of my TGS or advanced Kubernetes training or maybe Devops training, special lesson, so we go for multi-node cluster in the future. But right now, for first day, single node cluster is enough. Okay, and we are doing this thing with a tool called Minikube. My point is there's a lot of way to set up the Kubernetes. Whichever way you want, you can use. But after Kubernetes launch, okay, then all the command and setup and the vocabulary in the Kubernetes would be almost same. There might be some variation depending on the platform to platform, but at 99% everything would be the same. So for initial, you can use any setup to learn, but I feel this could be the quick way to get it done. As a free, you can install a laptop. You don't need to pay any charge to any cloud also. So we are going to use Minikube. Is a cube B here. So if you search how to install Kubernetes installed, that's what you can find. A lot of tools available in the market. How and where you want to install Kubernetes. If you want to install in a computer, or maybe I can say on premises. Okay, so there's a lot of way. Kind is also software we can use. Minikube, this is what I'm talking about. Kube ADM, if you want to create Kubernetes multi-node cluster, you can use. But right now I'm going to use Minikube. And there's a link from where you can get the Minikube. And they tell you the requirement that you run Minikube in your local system, laptop. Okay, only only prerequisite is for the Minikube. The prerequisite is, so let me write here. Okay, so if you would like to install, so what I'm guys doing at this point in time, so we are going to demo very quickly how to install the Kubernetes, because then we can learn the Kubernetes and see the demo. Okay, so the requirement would be you need your base OS. There's maybe in your case your laptop running with Windows or Mac and something like this. Okay, and on the top of this, you need some kind of virtualization tool. Maybe you can use Oracle VirtualBox. That's what you can use. For example, this is my laptop running with Windows, and you can go and download one of the virtual tool. Okay, out of this, what the name given. So in my case, I'm using Oracle VirtualBox, but you can use something else also. So if you want to install Oracle VirtualBox, you can search Oracle VirtualBox download. Okay, I think most of you guys might have already. If you don't have this tool, just go and download this tool, maybe for Windows. Double click, download and double click and install. That's pretty straightforward. So I'm just sharing this link to you. Okay, so it's a link to everyone. If you don't have this tool, you can install. That's one thing. In my case, I already have this tool, Oracle VirtualBox. Okay, now on the top of this, okay, what we will do, we will launch, because it is a virtual tool, and on the top of virtual tool, you guys might know we can launch one entire OS. Entire OS. And this OS is, guys, nothing. It will be your single node Kubernetes cluster. Okay, so in this OS will work as a work master node also. This OS is working as a slave node also for the Kubernetes. So this is a Kubernetes single node cluster. But who will do the setup? Entire setup. So we have some tool who can do the setup on the top of VirtualBox. Okay, and this tool is called Minikube. So this is the role of Minikube gonna come in play. Minikube. So we see here in the Minikube page. Okay, this is what we're talking about. We can use Minikube to do something on the VirtualBox, and I'm going to install for you the entire Kubernetes. Before this, you need Minikube software. So Minikube is also software. Okay, that will help you to install Kubernetes. So don't be confused. So Minikube is just a software, also known as installer, to install set up Kubernetes. Okay, that's what Minikube do for you. Okay, and for Minikube, the requirement is this one. So you can use VMware workstation if you have. You can use Hyper-V if you have. I think VirtualBox is a very common thing. Most of you guys might know. Otherwise, if it does not know, that's okay. You don't need to know VirtualBox. You just install. Go here and install it for you. Okay. So I'm doing this demo here very quickly. Okay. Then we give some time to you also. You can also do this setup. So you can do the further demo with me. Anyone who facing any issue, my team will be there online in multiple channels, Discord and WhatsApp group maybe, to help you if you're facing any issue. But how to install? Okay, so in my case, because my base computer is running with the Windows in my laptop, where I install the software. Okay, so you have to download the Minikube for Windows. So here, just go here, select the Windows, and download the exe file for the window. To download the exe file, there's a latest link here. I click on this link and they are downloading the Minikube for me. That's all. Minikube for me. And this is exe file. Okay, so let me run this file and this download into my my download location, I believe. So let me run this program. It will install Minikube in my local laptop. So they might say don't run, but let me run it because we can feel it's a genuine software. Run anyway. Yes. And technically what they're doing, they are installing Minikube. Okay, and Minikube is not the Kubernetes. This software is going to install Kubernetes. So first we need to install the software. I agree. Okay, and they're asking where to install Minikube. So let me install some location. Okay, but whichever location guy you install Minikube. So let me copy this location. We might need somewhere to do something with this location. So 1 minute. So this is the location in my case where they're going to install Minikube. Click install. That's all. So now Minikube has been installing. Now it's done. They install this software in my laptop somewhere, and wherever they store, in my case, let me finish, they install here. And why we need to know this location? Because this location, if I put in my Windows browser, my local explorer, it will take me here where they install Minikube, and this is what they give you. In my case, I have many more things you might not have. We don't require also. But main thing what you find here is this Minikube. So this is a location where they give you where they install Minikube, and technically they give you Minikube command. And this command we need to run. And to run this command, first we need to set my path in Windows, because Windows does not know where they installed. They install here. So whenever you install any software, if they give you a command, and if you want to run the command, there's a very common thing. We need to set up the environmental variable. Okay, so step by step, first we need to install Minikube. This is what we have to do by using this link. You can download and install. Okay, and then wherever they install, in my case they install here. So this is called path. So we have to set the environmental variable. How? So we'll go to Windows, just type env in Windows. You can find this environment variable panel. And here you just can go to environment variable button. And then there's a path. Just go and create a new path. Okay, in my case, I already did this part. So if you go to my edit, I already have this set. Somewhere I did, you can find somewhere. But I have this in my case. If you don't have, you can click and new and copy paste. So wherever you copied, you tell your Windows, this is the new location where new command gonna come up. New and set. Okay, so this is how we can set the environmental variable and say, okay, in my case we have many more, so we don't need, but in your case you can say okay and then okay and okay. Okay, that's all. So this is what you can do. So go to Windows, search, type env, then set environmental variable. Inside this, go and set the path and copy what you have above. That's all. And after you do this, that it means your Minikube has been installed. Now with the help of Minikube, we can install Kubernetes single node cluster very, very quickly. How? After you set the path, then open a new terminal. Don't use the previously old terminal. Open a new terminal, CMD, of your base system, in this case Windows. Okay, and then you run only one single command. One single command. You go Minikube start. That's all. That's what command, or they might also give you here. Minikube start. That's all. Okay, and you know what this command will do? It will set up everything for you automatically on the top of VirtualBox. So if you go to VirtualBox, in my case, I have nothing called Minikube or Kubernetes node here or VM here, same thing. But as soon as you run this command, Minikube now understood that you are running with Microsoft Windows, in my case, and you are running with VirtualBox, in my case. They auto detect this part for you, and then downloading some Minikube software behind the scene. Okay, so from the internet, so some size. Okay, and after downloading some software, they are going to set up Minikube single node Kubernetes cluster for you. They're downloading something about Kubernetes, that they have something preset Kubernetes for you, so you can practice all the Kubernetes thing. So technically, this was just one single command. Okay, in some few minutes, depending upon internet speed, you will have your Kubernetes up and running. So these are steps you need to follow. I'm just giving all the thing, copy paste in your chat message here in this Zoom. Okay, so I post everything here. Now they are setting up. So new VM. VM means new virtual machine, means new node. Okay, so you can see in some minute this node gonna come up here. Okay, so that's it, guys. Right now. So now next plan is I am opening the Q&A. Okay, so we'll do many things, guys, mostly. So after one small topic complete, then we open a Q&A. They can ask the queries to me till now, what will be discussed and whatever you want to know from me. And second thing, we mostly do quiz. Okay, so quiz is a way so that you guys can revise what we learned till now. Plus also you can understand your level of understanding is like a test actually. So we'll do a test in a minute. Okay, and after this we do a lab break time. In the lab break, what we learned till now you can practice. What we learned till now, whatever you want to practice. Okay, in this case you have to set up this part. And doing lab test, we have multiple channel, Discord and WhatsApp group, where any doubt is if you're facing, you guys can ask for my team. And then after this we will continue with training, but maybe after this we might have a lunch break time, so we'll do a lunch. That is the plan. So you can see a new computer gonna come up, and this computer is running with entire OS. This is called node, and in the OS they're running single node cluster, master node, and the worker node. But this is enough to doing most of the practical of the Kubernetes. Okay. Now, guys, any doubt if you have, you guys can ask me. Okay, any doubts anyone has? So can I use VMware? Yes, you can use Manyata VMware also. Okay, so whichever virtual software you want to use for Minikube, I have given you the list here. You can use. You can use, right? So anything. Okay, what is Cube ADM? Cube ADM is also one of the way to install Kubernetes. Right now, I'm installing the Kubernetes with Minikube software. It installed locally, single node cluster mostly. Okay, but if you want to set up the multi-node cluster in a very customized way according to your requirement, then we use this tool. Okay, so again, those who are part of my C, because guys, in the Kubernetes there's a multiple track also. Right now, what we are learning is a Kubernetes foundation. This is a prerequisite for any advanced thing. So what we are learning is a Kubernetes foundation training. Then after foundation, you guys can go for some specialized training of Kubernetes, like official training CKA, CKAD. That's what we guys can go. Okay, or maybe after foundation training, you guys can go for some other advanced Linux world custom training code that we done under TGS. Okay, or maybe you can go for special EKS training from AWS. Okay, so many things you guys can do. Okay, but when we go for this level of training, especially not EKS is a different service, but if you go for this training, there we normally have to do many advanced setup to be implemented in the world of Kubernetes, where we need multi-node cluster. So we will use kubeadm command to first create our own multi-node cluster, so that if there's some advanced thing where we need multi-node cluster, we can implement. Okay, anyone who want to join my TGS training, so there's a one website, tgsindia.tech. This is one of the Linux World initiative where I myself going to multiple cities offline. Okay, and we have multiple editions right now. The edition of Kubernetes is going on. It's a 3-day offline program. Okay, so we have participants from multiple companies, and this is the advanced detailed content. Not I'm saying advanced. We again start from very basic, but it is going to cover lots of Kubernetes detail, internal, advanced concept with integration of multiple other tools like Istio Service Mesh and Argo CD and a lot of CI/CD tool, lot of monitoring tool. Is a day one agenda. Okay, then we have day two. The integrate GitOps with Kubernetes, Prometheus Grafana with Kubernetes, DevSecOps security tool with the Kubernetes. Okay, and the last day, and that is very interesting. All the things we cover step by step with complete practice, full day training, 8+ hours offline. Then we do more advanced. Then we do some kind of caption project we'll create. And we also doing one more thing, guys. In the last day, we also calling a lot of technical talent acquisition team or HR team, because this program is meant to create an environment where everyone from the same domain come together. And we're also calling HR, so anyone who's looking for the job or hire and they're comfortable with the packages what those HR is offering, you guys can also switch and go for the job. Maybe you're the experienced guys or the freshers guys, or want to switch yourself in the world of container or in the world of DevOps. So a lot of things we plan over here. So multiple cities we are covering right now. The first one is Hyderabad, and 21st of 3rd May, Pune March, and Bengaluru March, Gurgaon and Chennai. So 5 cities we are covering. Anyone who nearby city, Mumbai guys can come to Pune, and those things you guys can do. It's a complete full day with us, and plus we're also calling a lot of this complete training is hands-on, practical, offline. Okay, delivered by me. But at same point in time, okay, for example, right now we start with Docker for some hour, from basic to all the advanced, what we need in Docker. And then we are calling some more from industry guys, maybe Docker captain or community head or some leader who work purely on Docker. So we have a quick lecture of this guy. Then we start Kubernetes, delivered by me. We call some more extra folks from the company, or maybe head of Kubernetes, maybe in the XYZ domain. They have a expert like this. So we have also good connections. Extra learning also happening together over here. Good thing is the connections. So only learning, if you want to grow in this world, only learning is not enough. Okay. So we try to reinvent the way learning or training should happen. So it's a mixture of learning, hands-on, lot of use case, project we build, lot of expert you connect offline. Same time you connect to right companies for the job. So multiple things we bring together. So it's an end-to-end package, I can say. That's what we plan in this TGS. So TGS is one of the initiative where we keep on coming with multiple different addition. So one is the Kubernetes, then we might come with some other tools. So it's a per quarterly or per half yearly, we come up with a lot of new tools under this the growth stream TGS. So those who want to join, you can join this offline, but I think this could be a next level of learning and training and connection. Okay, so that's what we can do. Can you please, when you host and node, same thing, Charles? So when I say host or when I say node, it is same thing. Node is a very common term in the world of cluster, because right now we're talking about a container cluster that is managed by Kubernetes. Managed by Kubernetes, but cluster is a very common term. We have compute cluster also that we use in HPC, high performance computing cluster. We use in Hadoop, for example, in distributed computing cluster, let's say map and reduce. So cluster is a very common term, but every cluster has their own use case. You want to manage storage, you want to manage computing, you want to manage cluster container. But here we are managing container, so we say container cluster. And in the world of cluster, okay, multiple computers work together. That's called node. So sometimes we can use the word node, and sometimes we can use the word host. Same thing. So there's no difference. Okay. So this is one thing. In TGS, guys, we are going to host you. So we will take care of all the 3-day lunch meal to you. We will give you the the workspace for the labs. So all those things will be taken care of from our side. From our side. Okay, but we have some coupons, right? Obviously, this training is not free, but obvious. So because we're hosting and giving all the things possible, but we have some coupons. I think you can connect to a team for multiple cities, not for every city. So some of the cities we have some coupons. Just to giving this awareness, this is what level of initiative we are coming up with. So you guys connect to our management team, whatever coupon that city is available. Okay, because we have opened the registration already for all the cities. So if the coupon is available extra for extra discount and something like this, my team will help you. Okay. Yes, this is completely offline. This is the different part, right? This offline learning obviously is a different experience of connections and learning. So Vamsi, this is just a path. So when I was installing the the Minikube, in my case they install here. So this is the location where my software installed. Okay, maybe in your case they've installed in the same location, maybe. Okay, but you have to tell to your computer where they installed. So I set the environment path. If you don't set this, then this command does not work. So before run this command, you have to set the environment. Means tell where they store, where they install. Then this command is working fine. And I believe, guys, this command is setting up the Kubernetes. A lot of things they're doing behind the scene. And I told you guys, in the Kubernetes, we need master node. Let's go control plane. So they're setting up the control plane node or the host. Let's go master node. Same master node, they are setting up the worker node. And the worker node is the one where we need engine. That's called Docker engine. So you can see they are also setting up the Docker engine. You can find somewhere. So there's a master node, and they are setting up the Docker engine together everywhere. I mean, the same computer. And if everything was great and fine, now I can find this message done. Which means my setup is successfully created and my cluster is up running in my local computer. And because running in the local computer, so there's no charge, it's free for you to use forever. Okay, so this is what is happening now. We are going to use this setup for doing all the Kubernetes practical. And while doing the practical, I'll show you lots of interesting keyword, many internal component of the Kubernetes. Okay, and the demo what I show you, if one of the pod goes down, so they will relaunch for you, and something like this we will see. Okay, in a minute, but let's have this setup ready. Then you can do the demo with me also together. Okay. So, but you have to wait, guys, for some time. This command will take some time to launch, depend upon your computer speed or the internet speed. So wait for some time; it will come up in some minute. Okay. So you have to create Minikube as a master node. No, Minikube is just a software, Prashant. Okay, for installing the Kubernetes. But Minikube will launch single node cluster, and this cluster they're running in this VM. But you don't need to install this VM. They will done everything for you. So this VM equal to host equals to node, whatever you say. But inside this VM, master node and slave node both working together. Okay, and how to use, that's the main part. From where the main features of the Kubernetes and learning of the Kubernetes we're going to start. Okay, in some time. Guys, one more thing. If you are facing any issue of launching the OS in Oracle VirtualBox, maybe sometime it might fail due to multiple different support in your laptop. Okay, so you can take the screenshot and put in the Discord channel. My team will help you. One of the challenges could be for launching any OS, let's say VM in the Oracle VirtualBox, you need some virtualization support in your BIOS. Means this is your laptop Windows. So shut down your Windows and then again start. And while starting, initially they ask you to go to BIOS by pressing F2 or Del and F10, depending upon the shortcut, whatever you have. Okay, go to BIOS and advanced or CPU configuration. You might find virtualization support that might be disabled in your case. So just go and enable this. And after you enable, then again start your Windows by saving with F10, I believe. And then again command run this command minikube start. So this could be one of the possible error if something is failing by running this command. In my case, it's not failing, but in your case, somewhere here they might fail because of that reason. That could be one of the reason why it failed. No, Manoj, the Docker desktop is not fine because we are not using Docker, we are using Kubernetes. So we don't need any Docker. I show you demo today just to quickly give you the high level idea what Docker is not doing for you. Okay, otherwise for this training, you don't need as such the Docker knowledge or neither the Docker setup you need. So we don't need Docker desktop. Okay, there's a way we can set up Kubernetes also on the top of Docker. That is also a way we have, but it could be a long setup to be implemented at this point in time. Okay, I don't want to make you confused. The best way we can use Minikube to get our setup ready. And here this setup they give you admin power also, because some of the demo we might need in the future where we need admin power, root power of the Kubernetes. So some demo today what we are going to learn that could be run smoothly anywhere, but whenever you need any root power, that also we need this setup. So because there's a lot of way you can also run the Kubernetes in playground also. So there's a lot of online playground available. So search for Kubernetes playground. Okay, so a lot of playground labs available by multiple different community and the companies. Okay, so they also give you live Kubernetes, maybe free and somewhere like this. Okay, there's also we can use, but they give you limited power. Some of the setup where we need admin power thing might not work here. Okay, might not work, depend upon what they give you setup, and this is not in our control. So rather than what we are going to do, we are launching right now with Minikube that can do everything for you almost. Or in the future, we will run multi node Kubernetes. They have an entire setup for entire power to be implemented. But for today, this is enough. Minikube. Different between the cluster and node, nothing. Multiple node together become cluster. That's all. That's called cluster. So if you see here, these are individual node work together, become a cluster. Okay. My team can confirm me. Are we doing quiz? Yes, Harshvardhan, you can do in EC2 also, but for this you have to set up in EC2. I'm not going right now, but when I show you multi-node cluster in upcoming class and discussion, then you can use that knowledge to set up in EC2 also in AWS cloud. I'm excited to attend a TGS in Gurgaon location. Okay. No, this training, Imran, is not DevSecOps, but DevSecOps we implement in Kubernetes. So whatever Kubernetes related DevSecOps concept we will implement there. So this training is around Kubernetes. The Kubernetes is not the only DAG tool we use as is. Along with Kubernetes, we integrate Kubernetes many with other tools. So first, obviously, we are going to learn Kubernetes step by step to all the advance. Then I'll show you how to integrate with Jenkins and Argo CD, Prometheus, Grafana, DevSecOps tools. Okay, so further integration also we will learn. So that's one of the cool part of this training. It's not only Kubernetes with many advanced tool integration to have an entire setup what we need in the industry. Okay. So, so TGS, there's no prerequisite, Sumit. Okay, mostly the if you whatever need in the Kubernetes I have put here. For example, For example, in Kubernetes, sometimes we need Docker, sometime. So I'm just starting from Docker. Okay, then we start very basic from the Kubernetes here, fundamental we start. So there's no prerequisite. But the way I plan this program, okay, I put all the component what we need in the industry. There were a lot of things maybe we don't need in the industry. We remove it from here because we don't need. Okay, so that is one of the reasons why in 3 days we are covering everything about Kubernetes with all the advanced tool integrations. So there's no prerequisite for this program. So if you're any facing issue, Nelson, what issue you're facing? I think you share some screen. So I suggest, Nelson, because there's possibility every laptop have on different challenge in setting up. I suggest my team has shared. Sayed, if you can again share the link of Discord channel. Okay, and also we're trying to open the WhatsApp group where you guys are connected for this training of foundation, so everyone can help each other for the setup. Yes, Srijit, we have. So we also have some AI tool of Kubernetes that will, with GPT AI, we can do all the setup. We can do all the things in the world of Kubernetes. That's also we have. In this training, I'm not covering because my plan is to teach you the concept with practical. But anyone who want to set up everything in the Kubernetes or using the Kubernetes with the help of AI tool like Gen AI tool, so I have very interesting codes, guys, completely built in a way that anything you want to do in the DevOps world or in the Kubernetes world with the complete AI. So very exclusive course, guys, I delivered long back, and one more course I hosted in Udemy also. Mostly we don't have a footprint in Udemy actually. We have our own portal, hash 13. But some of the course we launch here. So we search my name in Vimal Daga in Udemy. Recently, we start posting some courses here. Okay. So there's one course you can find is this one, Prompt DevOps. Okay. And if you click on this course, so this is recently we posted, very new. Okay, and what you find, this course is completely DevOps course, but this DevOps is being completely managed by Gen AI or AI. So whatever we main tool we use in the world of DevOps or Docker or Terraform and Kubernetes with a lot of tool integration. Okay, so I show you the entire advanced setup or integration lot of projects here. Okay, but with the help of AI. Without, it means if you have knowledge also. Okay, the entire setup to be done with the AI. So it's again very beautiful course. Okay, and lot of, it's a complete practical hands-on, but AI is controlling everything. So I'll tell my AI, hey, do so this thing Kubernetes, and a lot of prompt we learn, a lot of different tools available in the world of Kubernetes, like K8, SGPT, and many tool like Brainboard, and many other tools also we use. So this, if you guys want, you can go for this program. Someone asking, can we do with Kubernetes? Yes, why not? You guys can use this kind of tools. I'm sharing this link to you. You guys can join if you want to join. Yes, Krishna, you can apply for CKS after this 3 day of TGS training. Okay, so we have guys share the Discord link. Any doubt facing, put the errors over there. Should I learn DevOps or just if you are looking others for proper SRE or DevOps job, Kubernetes is one of the very important tool. Okay, but only Kubernetes is not enough. With Kubernetes, we have to go for learn Ansible, Terraform, Jenkins, and Prometheus, and Grafana, and Docker, and many other tools also that become a complete DevOps. Because right now, if you follow along Linux world, and we have a edit platform where we keep on coming up with a lot of new jobs for experienced guys and for the freshers. You can see most of the jobs is coming in the DevOps at this point in time, that you know from LinkedIn also. But all the DevOps job is around Kubernetes, but only Kubernetes is not enough. We have to use many other tools also. So, but one is, yes, we have a huge job and we have huge salary packages also. Even though recently we are also helping a lot of freshers. Getting the job for the freshers in DevOps is very hard, but we are getting a lot of jobs. Okay, so recently we got Deloitte for the fresher, and Kubernetes can do for you. As we go ahead, we will discuss. But I would like to jump to the practical. But for practical, I need Minikube setup. Now the setup is done. Now we can move to practical in some minute. Okay, before this, let me take the Q&A first. So add one more city, Bhubaneswar, in the TGS offline. Maybe we will definitely try Chandan, but right now we are just covering these cities only. Okay, at this point in time. So yeah, I think almost all the main query what you guys are asking, we have done. Okay, so I think one of my team member also share guys one command here. Okay, so if you guys facing the issue of VTX support, then I think this is the one thing you can try. I'm sharing this command in your chat box in Zoom meeting. While starting Minikube start, if you're facing an issue of VTX support and some virtualization support, then there's one of the command you can use, no VTX check. This command I've shared you here, that also can try. Okay, so yes, Umil, you can use Hyper-V also. So VirtualBox is not there, then if Hyper-V is enabled, they will detect and they use Hyper-V. Otherwise, there's also called driver option to can pass the Hyper-V as a driver to use. But I suggest guys, you can again try to follow with the same software. So those who not so much know about technology, so they will be sync with me. Otherwise, you're comfortable with Hyper-V or VMware, then you can use that driver in the virtual program. So a lot of guys saying they install successfully, fantastic. No, you don't need to install Docker JS. So inside this, guys, they given you Docker install. Docker install. So now after the setup done, and you click this is the new VM running with Linux and running with Kubernetes, running with Docker. Log into this guy. I think username is root. So when you type the username root, okay, you can log in. There's no password, and now you're inside this OS. And here they give you everything, whatever we need in the world of Kubernetes. But Kubernetes because rely on Docker, so they give you Docker also. So Docker is there. Okay, and if you want to exit, log out, you can exit. I want to log in, yeah. But we don't need to work from here. We will do in different way. We'll use in different way Kubernetes. I just want to show you my system is working. Is a real OS, real computer, real host or node. A root is account to log in. But don't do anything from here. We're going to use this cluster or a single node cluster with Minikube in a different way. What and how we will discuss after the break. Okay, so that is one thing. So I think I've been somewhere asking for any coupon. So what I'll do, guys, for you guys, I'll try and ask my team because some guys saying this coupon the price is coming very high. Okay, in Udemy. So, guys, if you're really looking for this, have a quick quiz. So